Hi everybody, today I'm going to cover Module 3 Test Review. From problem numbers 12 to 22. So this is part 2. I have posted part 1 earlier. So today the number 12, we are going to use the synthetic division. So I'm going to write down the problem first, what is given on Connect Math. So this is the problem we are given. We have to find dividend, divisor, quotient, and remainder. So part A, we have to find the dividend. The dividend is the given problem itself. It's inside the box, and you have to write as a polynomial. So you have to multiply this by x, x squared, x to the third, x to the 4. You leave the first one. This is our constant. So the dividend is 3x to the 4 minus 13x to the third plus 1 times x squared is just x squared plus 13 times x minus 6. Okay. Part B, we are going to find the divisor. The divisor is the number outside, whatever the number we are dividing by, but you can write this one as a factor, which is x minus 4. So the answer is you have to write as a factor, which is x minus 4. Part C, we have to find the quotient. Quotient is the polynomial we get after we divide. So this is our quotient. So this is constant. This is x, x squared, x to the third. So we get 3x to the third minus x squared minus 3x plus 1. And the last one is the remainder. We have to find the remainder. Remainder is the last in the box. Inside this box, this is our remainder, which is negative 2. Okay. So let's go to problem number 13. So we are given a problem. It says use synthetic division. To divide the polynomial by x plus 2. So the first question in part 1 is to use the synthetic division. The divisor must be in the form. So the divisor in the form of x minus c. Here, what is c? C is going to be the number from here, which is switching the sign. So this c is going to be negative 2. Then part 2 is this is the question given. 6, 17, 7, and we have to write the answer here. What is going here? You have to multiply 6 and negative 2, which is negative 12. That is the answer. And you have to write the final answer here, which is going to be 17 minus 12 is 5. And part 3, you have to continue that. So 5 times negative 2 is negative 10, and the remainder is negative 3. So these are the answers. And part 4 is you have to write the quotient. So the quotient is the last row, which is 6x plus 5. And the remainder is negative 3. And number 5, you have to write the final answer. The final answer is quotient plus remainder over divisor. So the quotient is 6x plus 5, and the remainder is negative 3. The divisor is x plus 2. So that is our final answer. So next we are moving on to number 14. Again, we are going to use synthetic division for this polynomial. So we have to switch the sign here. So it's going to be positive 5. So we're going to divide this polynomial by 5. And make sure you have all the terms in the polynomial, and the polynomial has to be in the descending order. So we are writing 0 here. So the answer is 5x. The answer for this problem is 5x plus 18. Okay. Now, next number, problem number 15. We are given a polynomial k of x. So part A, we are going to evaluate k of 2. It's just the regular one, what we have learned earlier. We have to find k of 2. That means you have to plug in 2 for all the x here. So let's do that. So we get 2 times 2 to the power 4 is 16 minus 4 times 8 plus 2 times 4 minus 5. So we are getting 3. So k of 2 is 3. Okay. Next, part 2 is we are going to evaluate using the remainder theorem. So now part B is we are going to use the remainder theorem. So by remainder theorem, all we have to do is divide the polynomial by 2. So you put the 2, x to the power 4, x to the power 3 is -4, x squared is 2, but x term is missing, so I have to put 0 for that and put the constant term. So let's see if we are getting 2. 2 times 2 is 4. 4 minus 4 is 0. 2. 4. 4 times 2 is 8. 0 plus 8 is, sorry, there I gotta put 0 here. 0. And then 2. So 2 times 2 is 4. So we put the 4 here. And then 4 times 2 is 8. 8 minus 5 is 3. So we are getting the same answer. So by using remainder theorem, f of 2 is also 3. Or here it's k. I'm so used to f. So k of 2 is 3 as well. So next we are moving on to problem number 16. So use the remainder theorem to evaluate the functions. So we're going to use remainder theorem. So for f of x equals so part A, we are going to find f of -1. That means we are going to divide this polynomial by -1. Make sure all the terms are there and make sure it's in the descending order. -2. And then we have -11. Multiply, we get +11. When we add, we get 13. And then -13. So we have 21. And it's going to be -21. So the answer is -11. So the final answer is f of -1 is -11. Okay. Next, moving on to the next one, we have to find f of 2. This is part B. So it's going, we are going to divide the polynomial by 2. So we always have to multiply. So -16. It's going to be 18. 18 times 2 is 36. When we add, we get 46. So f of 2 is 46. Okay. The next one we are going to find f of 1. The next question is find f of 1. So we're going to divide, use synthetic division and get the remainder. The remainder is always going to be the answer for evaluating the function. 1 times 2. So 29 times 1 is 29. So the answer is 39, which is the remainder. So that is going to be our answer. F of 1 is 39. The last part of this problem is a fraction. So we have to find f of 5. Let me check. F of 5 over 2. F of 5 has you can use your calculator when you're multiplying fractions. So we have 2. 5 halves is 5, so negative 4. It's going to be negative 20. Negative 18 is negative 9 is negative 45. So 1 second, let me make sure I'm getting the right answer. Okay, negative 4, negative 8. Sorry, this is negative 10. So we get negative 8. Then this is going to be negative 20. We get 14. So it's going to be 35. So the answer is 45. Okay. So f of 5 half is 45. Okay. So this is the calculator when you're multiplying fractions. Next one, we are going to do number 17. Use the remainder theorem to determine if the number c is a zero of the polynomial. So we are going to use the remainder theorem to find if the number, if given number c is a zero of the polynomial. Okay, so how do I find out? So this is the given polynomial. Okay, so the first one we are going to check if the first problem is c is negative 2. So we have to divide this by negative 2 and see if it is a 0. Make sure all the terms are in the polynomial. So if we get the remainder as 0, that means negative 2 is a 0 of this polynomial. So we are getting 0. That means this c equal to negative 2 is a 0 of the polynomial. Next, part B is c equal to 6 divided by 6. I don't think so. It's going. So it's becoming bigger and bigger. I don't think we are going to get a 0 here. So 272 times 6 is 1632. And obviously we are not getting 0, so it's not. So C equal to 6 is not a 0. Because we have to get 0 as the remainder. So let's move on to number 18. So use the factor theorem, we have to find if the given binomial is a factor. So we are given a polynomial. So first thing we have to check if x plus 2, to find if x plus 2 is a factor of f of x. In other words, you have to switch the sign here, which is -2, and divide the polynomial by -2 and see if you are getting 0 as the remainder. I'm sorry, this is 38. That's why I was wondering why I'm not kidding. So this is 38. So 19, -38, 0. So yes, we are getting 0. So x plus 2 is a factor. Okay. So this is part A. Part B is we have to check. Second question is we have to find out if x minus 1 is a factor. We are going to check. We have to divide by +1. So put 1, 1, 9, 9, 14, 14, 19, 19. Nope, we are not getting 0. So x minus 1 is not a factor. Okay. So that is question number 18. So we're moving on to the next one. Number 19. So we are given g of x. So part A, we have to evaluate g of square root of 7. So you can put square root of 7. And this one 1 and x to the power 3 is missing, so put 0. And then x squared. And again x to the power 1 is missing, so I'm putting 0. So it's going to be 175. And this 1 times square root of 7 is square root of 7. Square root of 7 times square root of 7 is just 7. So we get -45. negative 45 times square root of 7. So next, negative square root of 45 times 7 is going to be negative 175. So which is 0. So we are getting g of square root of 7 is going to be 0. Part B, we have to find g of negative square root of 7. That is also going to be 0 because the power is 4. If you plug in minus square root of 7, that is also going to be 0. And part 3, we have to write the solution set. So we have to find the solution. Part C, we have to solve g of x equal to 0. So when you break it down, when you find the factors of 175, which is going to be negative 25x squared minus 7x plus 175. So we're going to solve using grouping. Group these two. So I'm going to so let's add. So we have I'm writing. So I'm rewriting the expression 25x squared minus 7x squared plus 175 equal to 0. Group 2 by 2. So x squared is common. And here we can take that 7 outside. And if you notice, we have x squared minus 25 is common in both. So that is our common factor. So we set each one equal to 0. Then solve for x. So we get x squared equal to 25. We take the square root. You have to put plus or minus. So we get x equals plus or minus 5. Here we get x squared equal to 7. We have it's already given in the problem. So it's going to be plus or minus 7. So x is going to be. So finally, we have to write the solutions. Solutions are 5 minus 5 square root of 7 and minus square root of 7. Okay. So next we are moving on to number 20. Problem number 20 is we have to find, we are given a polynomial. Now we have to factor this. Okay. So part A, part 1, we are given negative 2 is a 0. So divide by -2. We get 0 because -2 is a 0. Now we have to factor this trinomial. So you have to multiply -42 times 4, and you have -168. That is 8 times c, and you have to get the b, which is 17, which is going to be, the two numbers are 24 and 7. We use grouping. So we have 4x is common. Then we have x plus 6 is common. So we are getting x plus 6 equal to 0. And so x equals -6. And 4x minus 7 equal to 0. So add 7. So we get 4x equal to 7. X equals 7/4. So the zeros are, we can list the zeros here, or the solutions is -2, 7/4, and -6. And I'm going to write the factors. So the factors, we can write the f of x as f of x equals 4x minus 7 times x plus 6 times x plus 2. So these are the answers for number 20. Next, we are going to solve number 21. It's the synthetic division. I think you can do this. So let's first so we are given a polynomial f of x equals given that 2 is a 0. So first question, we have to factor. So 2 is a 0 means x minus 2 is a factor. So let's first divide by 2. So we are getting 0 because 2 is a 0, right? This is part A. The next question is, we have to write the quotient. We have to write the answer as the divisor plus quotient. So this is the question here. Write the answer as divisor times quotient plus remainder. The divisor is x minus 2. Quotient is 16x squared minus 40x plus 25 and the remainder is 0. In part 3, you have to write as a factor form. So the question is, write factored form. Which is x minus 2 times 4x minus 5 squared. So you are going to write this one as, because I will show you the work here. So you have to multiply. It's a perfect square binomial. The square root of 16 is 4 and 25 is 5 and the middle sign is 5. So it's going to be twice. So it's going to be 4x minus 5 times 4x minus 5. That's what we got here. And the last part is we have to solve. So to solve, we have to set this x minus 2 times 4x minus 5 squared equal to 0. And set each one equal to 0. And solve and get the x by itself. So x equal to 2 is our first solution. And x equals 5 over 4 is our second solution. Okay. And the last one is I'm going to solve number 22. So we are given, we have to write a polynomial f of x for the given conditions. Which is degree 3 with zeros, 3, 6, and -4. So we are going to write a polynomial. 0, 3 means x minus 3 is a factor. 0, 6 means x minus 6 is a factor. And you have to switch the sign. Remember? Now we are going to FOIL these two first. So we get x squared minus 6x minus 3x plus 18. And times x plus 4. So combine the like terms here. And then we are going to multiply again. So we get x to the third plus 4x squared. Then minus 9x squared minus 36x plus 18x plus 72. So you multiply the polynomial and combine the like terms. Minus 18x plus 72. So this is the required polynomial we got. Okay. So these are the problems from 12 to 22. So the rest of the problems I will post. Until then, bye.